So first, we'll start one by one. Okay. Solution. Okay. Yeah. So first, what was asked? The dryness fraction, which is nothing but the quality of steam at state 2. That is nothing but the value of x2 was being questioned. Okay. How did you do this? For this, first you require the value of few parameters. Okay. First, you might have to calculate the value of h1. So h1 lies in the state 1. So state 1 is in which state? Yes. State 1 lies in which state?
Saturated vapor line.
It's on the saturated vapor line. So if it is on the saturated vapor line, how well is supposed to calculate the enthalpy?
Hg.
Hg, okay. Okay. So state 1 is on the saturated vapor line. So therefore, H1 is equals to Hg at a pressure of, what is the state 1 pressure? So 25 bar. So at 25 bar, what is the value of Hg from the steam tables? Yes. Hg at a pressure of 25 bar is the value of H1. What is the value of H1 then? Any disturbance in the voice? Is there any disturbance in the voice?
No, sir.
Okay. So please tell me the value of H1, look into the steam table and give me the value of H1.
Sir, 2800.9.
2800.9 kilojoules per kg it is. So when you multiply this particular value with the value of m dot, what you have? So m dot is in kilojoules per kg, m dot is in kgs per second. So what happens, kg get cancels, joules per second is watt, so it is kilowatt.
Sir, now there is some disturbance.
I guess someone's mic is on. Okay.
It feels like echo, sir. Echo.
Echo? Okay, is there an echo while I'm talking here?
No, sir.
Okay. So fine. What is the value of H1 now in kilowatts? So m dot value is how much? 10.
10.
Give me the proper units, man. So can I write it as 28 into 10 to the power of 3 kilowatts? Is it correct?
Yes, sir.
Okay. So now H1 is done. Now you need to find the value of H2. So in order to find H2, what is the key rule I have said you? What you have to find in order to find H2? In order to find H2, you require always the value of X2. In order to find the value of X2, you require to equate S1 is equals to S2. So keep this in a box so that you will have a sequence of steps in your mind always. So in order to find H2, you require X2. In order to find X2, you require to correlate S1 is equals to S2. You can use this relation S1 is equals to S2 because it would be an isentropic process. Now, H2 is in state 2, and this particular state 2 is in wet region. So, in wet region, the formula is HF plus X into HFG. All these values are taken at state 2. Okay. What is the state 2 pressure? State 2 pressure. It
Point
is
2 bar.
2 bar. Okay. So it is 0.2 bar. So from steam tables again, what we have is the values of HF and HFG at 0.2 bar. Please give me the values of HF and HFG at 0.2
Two.
bar.
251.5.
251.5 is the value of HF plus X2 into
2358.4.
2358.4. So all this would be in kilojoules per kg. Remember this. Okay. So whatever the value you get, it would be in kilojoules per kg. Okay. One thing, guys, I have already multiplied here in m. So if you multiply here into m, so all the things will be in kilowatts. Again, you need not multiply while you are calculating H1 minus of H2, that is pumping work and turbine work. Okay, so what we will do is we will not make it complicated. We'll keep it in kilojoules per kg itself. Later on, we shall look at it. Okay. Again, you get confused. ಏನೋ ನಾನು ಹೊಸದು ಮಾಡಿದ್ದೀನಿ ಅಂದ್ಕೊಂಡ್ಬಿಡ್ತೀರ ನೀವೆಲ್ಲ. Now, so yes, while calculating the value of H2, I got a complication. I don't know the value of X2. So that is what is indicated in the rule here. So in order to find X2, what should I do? In order to find H2, what should I do? Yes,
Entropy equation में होती है.
you have to correlate entropy. Okay. Have to always correlate entropy, that is S1 is equals to S2 since state 1 to state 2 is an isentropic process. Entropy remains same. Fine. So S1 is in the state 1 and S2 is in the state 2. Now, state 1 is on vapor line and state 2 is on where? Where is state 2?
Wet region.
So wet region. So if it is on the vapor line, how will you calculate the value of entropy? If it is on the vapor line, S1 is equals to, yes,
SG.
SG, correct. T at a P1 equal to how much? 25 bar. 25 bar. So SG at P1 equal to 25 bar. Okay, so that is equal to S2. So S2 is in the wet region. So how will you calculate S2?
SF into X into SFG.
SF plus X into SFG. So all this are at a pressure of P2, which is equals to 0.2 bar. So from steam tables, again, you can write that. From steam tables, we have. So what is the value of SG from steam tables?
7.9094.
7.9094. That is equals to, what is the value of SF at a pressure of 0.2 bar?
Sir, wrong. SG, I got value of 0.2 bar, sir.
25 barrel notebook. That is why I have written. Why I have written this is you will get confused. So that is why S1 in the sense you have to look for state 1. So state 1 is in 25 bar. Okay. S2 in the sense you have to look for state 2. State 2 is in what? State 2 is in 0.2 bar. Okay. Be careful.
6.2537, sir. SG.
6.2537 is the value of SG at 25 bar. Now, give me the value of ESF
0.8321.
0.8321 is the value of SF plus X2 you need to find. Now, SFG at 0.2 bar.
7.0773.
7.0
Double 73.
773. From this, can I have the value of X2? ಎಷ್ಟು ಬೇಕು ಎಷ್ಟು ಮಾಡಲಿಕ್ಕೆ
0.766.
0.766. So I will just write it in a box. And this is what it was asked previous. Okay, solution 1, which is the dryness fraction at state 2, which was being asked. Okay, now I got the solution for the same thing. So x2 is how much? x2 is this much. Okay. Once that is done, so you can use the above formula, which is here, H2. So I would just call this as equation number 1. I will pick that equation once again. Okay. So I would just write from 1 okay. Now from this calculate the value of H2. It is 251.5 plus x2 is 0.766 into 2358.4. So from this, what is the value of H2? Keep it in kilojoules per kg itself.
2058.03.
2058.03. Now, immediately once you have calculated the value of H2, go with state 3, which is H3. So state 3 is in which region? It is on the saturated liquid line. So if it is on the saturated liquid line, what is the value of H3? That is equals to HF at state 3. That is at the pressure of P3. What is the pressure of P3? Again, it is 0.2 bar. Now, what from steam tables? So, what we have the value of H3 as in kilojoules per kg. Okay. Yes, look into the steam tables. Give me the value of H.
251.5.
It is 251.5 kilojoules per kg. Now, H4 is at the state 4 and state 4 is in liquid region. So what is the golden rule I have given you? In order to find H4, what is the golden rule? So what is the golden rule that I have given you? In order to find H4.
Find the pumping work.
Find the pumping work. So first find pumping work. Okay, so put it in a box. Are you able to hear the other class voice?
No, sir.
Good. Pumping work. So pumping work done by a pump. Again, I will pick up that TS diagram once again in this page. Okay. Now, so if you look at this, so pumping work happens from where to where?
3 to 4.
It happens from 3 to 4. So that's why for work it is initial minus final. This work is going from 3 to 4. So how will you calculate in terms of enthalpy?
H3 minus H4.
H3 minus H4. What is the other way that I can calculate my pumping work as I've given in the last class?
WP is equal to V3 into P3 minus P4.
V3 into it is P3 minus of P4. Do I have the value of V3?
No.
So that thing have to be found out. So we'll calculate it. So V3 is on the state 3. So state 3 is on saturated liquid line. So if it is on the saturated liquid line, V3 is what? V3 is Vf at state 3. Okay. For a pressure at 3, which is equal to 0.2 bar. Now, if I calculate the value of Vf at 0.2 bar, so that will be the value of V3 now. So you will get, hopefully, so from steam tables you have, write that sentence once again. Yes.
Zero
0
point
point
Yes, 0 point
double zero
zero
one
zero
zero
one
one.
zero one
0010172
7 2.
is the value, right?
Yes.
Okay. Now
Meter cube per
remember,
kg.
okay, meter cube per kg. Remember, when you are substituting in order to calculate WP, you have to substitute in Newton per meter square. Mass the units will come to know if you have a doubt. Cross P3 value. What is the pressure at state 3? It is 0.2 bar, so it is 0.2 into 10 to the power of 5 Newton per meter square minus the value of P4, which is at the state 4. And state 4 pressure is 25 bar, so it is 25 cross 10 to the power of 5. So match the units if you have a doubt. You can match it here. Okay, we'll just do it. V3 would be in meter cube per kg. Cross pressure would be in Newton per meter square. So meter get cancelled. So Newton meter per kg. Okay, what is Newton meter? Yes, what is Newton meters? It is joules per kg. Now, whatever you get the value would be in kilojoules per kg. Yes, what is the pumping work?
Minus 0.025.
Minus 0.02522.
2522.
Okay. Have you taken this 10 to the power of 5?
Oh, no, sir. No. Sorry.
That's why I told you, match the units. Substitute in Newton per meter square.
Minus 2522.65.
Minus 2522.65. So as the units what we have matched, it would be in joules per kg. So I'll be writing joules per kg, but can I just make it as minus 2.52 kilojoules per kg, right?
Yes, sir.
Okay, right. So WP is being obtained. Next, you can use the other relations of WP also. We have what we have, that WP is equal to what? H3 minus of H4. WP is minus 2.52 kilojoules. H3 is 253.92. Allah, 251.40 minus the value of H4. So from this, can I have the value of H4 in kilojoules per kg?
253.92.
Exactly. So it is 253.92. Okay. So once the value of H1, H2, H3 and H4 are calculated, I think no one can stop you in calculating the rest of the things which is asked. Okay. So second thing what was asked is,
Turbine work.
turbine work and pumping work, isn't it? Okay. Yeah. So turbine work, so WT, turbine work happens from where to where? It happens from 1 to 2. So for work it is initial minus final, so it is H1 minus of H2. Since mass flow rate is given, you have to multiply it by m dot. Now, please substitute the value and calculate the turbine work. It is 2801.7 minus 2067.29 multiplied by m dot value was cross 10. So whatever you get the value now, that would be in kilowatts.
Sir, H1 2800.9.
ತೊಂದರೆ ಇಲ್ಲ, ನಾನು ಇದು ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಇಂದ ಡೈರೆಕ್ಟ್ ತಗೊಂಡಿದ್ದೇನೆ, ಸ್ವಲ್ಪ ಡಿಫ್ರೆನ್ಸ್ ಇರ್ತದೆ. 28 ಎಷ್ಟು ಬಂದಿದೆ ಹೇಳು?
2800.9. H2 changes, sir.
ಎಷ್ಟಿದೆ ಹೇಳು? ಇದು ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ವ್ಯಾಲ್ಯೂ ನಾನು ಡೈರೆಕ್ಟ್ ತಗೊಂಡೆ.
2058.03.
ಎಷ್ಟು ಬಂತು ಈಗ ವ್ಯಾಲ್ಯೂ?
$7428.7.
7428.7 kilowatts. Next, ಈಗ ಥರ್ಡ್ ಪಂಪಿಂಗ್ ವರ್ಕ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ಸೊ ಪಂಪಿಂಗ್ ವರ್ಕ್ ಆಲ್ರೆಡಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ದೇವಲ್ಲ. ಸೊ ಪಂಪಿಂಗ್ ವರ್ಕ್ is equal to W 3 to 4. So W3 to 4 under it is H3 initial minus final H4 cross m dot. ಈ H3 ಮತ್ತು H4 ವ್ಯಾಲ್ಯೂ ಡೈರೆಕ್ಟ್ ಆಗಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ರೆ ನೀವು ಆಲ್ರೆಡಿ ಸಮಥಿಂಗ್ ಏನೋ ಬಂದಿದೆ ಅಲ್ಲ, minus 2.52 kilojoules per kg. So I would just write minus 2.52 kilojoules per kg cross 10. So it is minus 25.2 kilowatts. So that is your pumping work. Okay. Clear, Aita? Any doubts?
Yes, sir.
Next, fourth one. Fourth one in ಕೇಳಿದ್ದಾರೆ
Work ratio.
work ratio. Work ratio already ಹೇಳಿದ್ದೇವೆ. Work ratio is what? What is work
Network.
ratio?
Network by positive.
It is net work divided by positive work. So net work is turbine work plus pump work. Positive ಅದರಲ್ಲಿ ಇರೋದೊಂದೇ, that is turbine. So substitute the values and get it. It is 7482.87 minus 25.2 divided by 7428.7. So work ratio is
0.9966.
0.9966. Correct? ಈ ಟರ್ಬೈನ್ ವರ್ಕ್ ಕರೆಕ್ಟ್ ಉಂಟಾ?
Yes, sir. 7428.7, sir. 7428.7 kilowatt.
ಅಲ್ಲ ಕಣೋ, 2800 ನಿಂದು ಮ್ಯಾಕ್ಸಿಮಮ್ ವ್ಯಾಲ್ಯೂ ಇದೆ. 7428 ಹೇಗೆ ಬರುತ್ತೆ? ಹ್ಮ್ 742.87 ಅಲ್ವಾ? ಇಂಟು 10 ಅಲ್ಲ? ಟನ್. Right, done. Correct. Fifth one ಏನು?
ಸರ್ ಇದು ಪಂಪಿಂಗ್ ವರ್ಕಿಗೆ ಅದು ಮಾಸ್ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಲಿಲ್ಲ ಸರ್?
ಮಾಡಿದ್ದೇವಲ್ಲ ಈಗ. ಮಾಡಿದ್ದೇವಲ್ಲ ಇಲ್ಲಿ.
ಹೌದು ಸರ್.
ಫಿಫ್ತ್ ಒನ್ ಏನು ಕೇಳಿದನು?
Efficiency of Rankine cycle.
ಓಕೆ, ಎಫಿಷಿಯನ್ಸಿ ಮಾಡಿ, ಈಸಿ ಅಲ್ಲ. ಸೊ ಎಫಿಷಿಯನ್ಸಿ of Rankine cycle, how it is calculated? That is equals to output divided by input. So output in the sense it is total work. Output, input in the sense it is heat supplied. Total work output is WT plus WP divided by heat supplied. I guess you have the values of WT and WP but not QS. So QS ಹೇಗೆ substitute ಮಾಡೋದು? Heat supplied is from where to where?
4 to 1.
The heat supplied is from 4 to 1. So for heat it is final minus initial, it is H1 minus of H4. Since the value of m dot is given, multiply it. So that you'll get it in kilowatts. So it is 2, 5, ಅಲ್ಲ H1 ವ್ಯಾಲ್ಯೂ ಎಷ್ಟಿದೆ 2801 ನಿಮ್ಮ ವ್ಯಾಲ್ಯೂಸ್ ಕೊಡೋ ಈ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ವ್ಯಾಲ್ಯೂ ಮತ್ತೆ
2800.9.
2800.9 minus H4
253.92.
253.92. So multiplied by 10. So this is the value of QS. Whatever you get, you will get it in kilowatts.
25469.8.
25469.8. Now go with the efficiency of Rankine now. Turbine work ಎಷ್ಟು ಬಂದಿದೆ ನಿಮಗೆ 7 ಇದೆಲ್ಲ okay so divided by 25469.8 so when you multiply it by 100 so you'll get efficiency of Rankine cycle in percentage.
Sir, pumping work value minus ಅಲ್ಲಿ ಇದೆ sir.
ಮೈನಸ್ ಅಲ್ಲೆಲ್ಲ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ
ಆ ಫಾರ್ಮುಲಾ ಕರೆಕ್ಟ್ ಸರ್.
ಆ ಥರ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಇರಬೇಕು ಡಿಸ್ಕಸ್ ಮಾಡಿದಾಗೆಲ್ಲ ಗೆಟ್ ಕ್ಲಾರಿಟಿ ಅಬೌಟ್ ದ ಪ್ರಾಬ್ಲಮ್ Rankine cycle ಎಷ್ಟು ಬಂತು ಎಫಿಷಿಯನ್ಸಿ
29%.
29.06.
ಸೊ ಇಷ್ಟೇ ನೋಡಿ 29.06 ಅಷ್ಟೇ ಇದರದ್ದು ಎಫಿಷಿಯನ್ಸಿ ನೆಕ್ಸ್ಟ್ ಲಾಸ್ಟ್ ಒಂದೇನೋ ಬಿಟ್ಟು ಕೇಳಿದಾನಲ್ಲ 6th one
Heat lost in condenser.
so heat lost in condenser ಹೇಗೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀರಾ heat lost in condenser
H3 minus H2.
it is happens from 2 to 3 so for heat it is final minus initials of H3 minus of H2 cross m dot now substitute the values H3 ಎಷ್ಟಿದೆ 251.5 so it is 251.5 minus the values of H2 2058.03 2058.03 multiplied by 10 so this is the value of heat rejected in condenser in kilowatts. So if you give me this value, this problem ends here.
Minus 18075.3.
Minus
18075.3.
that's it. There ends your problem. Okay. Clear?
Sir.
Any doubt? Another doubt ಉಂಟಾ ಇದೆಯಲ್ಲ ಇದು ಬೇರೆ ಪ್ರಾಬ್ಲಮ್
ಇದೇ ಪ್ರಾಬ್ಲಮ್.
ಬೇರೆ ಪ್ರಾಬ್ಲಮ್ ಇದು ಸೇಮ್ ಪ್ರಾಬ್ಲಮ್ ಲಾಸ್ಟ್
ಬೇರೆ
ಪ್ರಾಬ್ಲಮ್
ಬೇರೆ ಪ್ರಾಬ್ಲಮ್ಸ್.
ಮಾಡುವ ಇದನ್ನು. Steam enters the turbine of its steam power plant operating on a Rankine cycle. It's operating on a Rankine cycle at 10 bar, 300 degree Celsius. The condenser pressure is 0.1 bar. Steam leaving the turbine is 90% dry. Calculate the adiabatic efficiency of the turbine and also the cycle efficiency, neglecting the pump work. Adiabatic efficiency ಹೀಗೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತಾರೆ. ಐಸೆಂಟ್ರೋಪಿಕ್ ಎಫಿಷಿಯನ್ಸಿ ಗೊತ್ತುಂಟಾ? How many of you remember adiabatic isentropic efficiency? ಎಷ್ಟು ಜನ ಗೊತ್ತಿದೆ? ಬ್ರೇಕ್ಡೌನ್ ಸೈಕಲ್ ಅಲ್ಲಿ ಮಾಡಿದ್ವಾ? ಎಫಿಷಿಯನ್ಸಿ ಆಫ್ ಟರ್ಬೈನ್, ಎಫಿಷಿಯನ್ಸಿ ಆಫ್ ಕಂಪ್ರೆಸರ್, ಅದೇ ಕಾನ್ಸೆಪ್ಟ್ ಬರುತ್ತೆ. ಪ್ಲೀಸ್ ಟೇಕ್ ದಿಸ್ ಪ್ರಾಬ್ಲಮ್, ವಿ ವಿಲ್ ಸಾಲ್ವ್ ಇಟ್. I don't have a solution though. Okay, I will do one thing. Okay, be ready with the problem. We'll solve it after 2 minutes. Okay, already time ಆಗಿದೆ ಅಲ್ಲ? ಸ್ವಲ್ಪ ಸ್ಟಾರ್ಟ್ ಮಾಡಿ ಬಿಡುವ. Okay. Shall we start the problem? So I was drawing both the diagrams, PV and TS diagram, just to make you understand the concepts. Okay. In examination, there is no compulsion that you have to draw both the diagrams. If you draw one of these, preferably not one of these, you must draw TS diagram. PV diagram is your choice. So if you have time, draw the PV diagram for more clear understanding of the problem. If you don't have time, then TS diagram is more than sufficient. Okay. Okay, this is A, B, 1 to 2 is isentropic expansion, 2 to 3 is condensation, and 3 to 4 is pumping work, 4 to E economizer, A to B boiler, B to 1 superheater. So 4 to 1 is nothing but your heat addition process. Typical TS diagram. Okay. Next. Okay, shall we start?
Yes, sir.
Okay, so two pressures would be there. One is the boiler pressure, you all know this, and other one is the condenser pressure. So just note down the values. It is 10 bar and it is 0.1 bar. Okay. Now, so this is the given data. Steam leaving the turbine is 90% dry. So what is this parameter given? Anyone? Steam leaving the turbine is 90% dry.
X.
Yes.
Dryness ratio.
Dryness ratio or dryness fraction. So X2 is given. It is 0.9. Okay. Let us start. So what he requires? He requires cycle efficiency, neglecting the pump work, cycle efficiency, and that means efficiency of Rankine cycle. So he has clearly mentioned that you have to neglect pumping work. Okay, so efficiency of Rankine cycle and then it is output divided by input. So output is work output, that is turbine work output, divided by input is the heat supplied, QS. Okay.
Sir, how we get to know that which one is boiler pressure, sir, in question?
Generally, if he specifies the Rankine cycle is operating at 10 bar and 30 degrees Celsius, that is fixed to be known that it is a boiler pressure and boiler temperature given or superheating temperature given. Even this 300 degrees Celsius, whatever he has given, it is inevitably understood that it is the value of 300 T1, which is 300 degrees Celsius. Because so when you speak about a bullet, first thing, what will you ask? When I have a Royal Enfield with you, first thing, what will ask? When I say I have a Royal Enfield,
ಪೆಟ್ರೋಲ್ ಹಾಕಿ
Mileage.
ಸರ್
huh?
Mileage.
ಪೆಟ್ರೋಲ್ ಜಾಸ್ತಿ ಸರ್
ಅಲ್ಲ ಕಣ, ನಾನು ಆ ಥರ ಹೇಳ್ತಾ ಇಲ್ಲ.
CC.
ಕ್ಲಾಸಿಕ್ ಆಗಿ ಹೇಳ್ತಾರೆ ಸರ್.
CC.
Exactly. CC, isn't it? Whether you will ask whether it is 350 cc or whether it is 500 cc.
Sound ಹೆಂಗಿತ್ತು ಕೇಳ್ತಾರೆ ಸರ್.
Huh? ಎಂತ?
ರಾಯಲ್ ಎನ್ಫೀಲ್ಡ್ ಸೌಂಡ್ ಹೆಂಗಿತ್ತು ಕೇಳ್ತಾರೆ.
ಕರೆಕ್ಟ್ ಕಣೋ. ನಾನು ಕಾನ್ಸೆಪ್ಟ್ ಕೇಳ್ತಾ ಇವಾಗ ಸಪೋಸ್ ನಿನ್ ಬೈಕ್ ಇದು ಪವರ್ ಹೇಗೆ ಅಳಲ್ತೀಯ? How do you calculate or get to know the power of a bike by its cc, isn't it?
Yes, sir.
ಕರೆಕ್ಟ್. ಯಾರೇ ಬೈಕ್ ತಗೊಳ್ಳಿ ಫಸ್ಟ್ ಕೇಳೋದೇನು, ಅದು ಎಷ್ಟು ಸಿ ಸಿ ಇದೆ ಅಂತ. ಬೇರೆಲ್ಲ ಪ್ಯಾರಾಮೀಟರ್ಸ್ ಸೆಕೆಂಡರಿ, ಮೈಲೇಜ್, ಸೌಂಡ್ ಇವೆಲ್ಲ ಸೆಕೆಂಡರಿ. ಬಟ್ ಪ್ರೈಮರಿಲಿ ನಾವೇನ್ ಕೇಳ್ತೇವೆ, ಎಷ್ಟು ಸಿ ಸಿ ಇದೆ ಅಂತ. ಹೌದು ತಾನೆ? ಹೌದಾ ಇಲ್ಲ? ಅದೇ ತರ ಒಂದು ಬಾಯ್ಲರ್ ಅಂತ ಹೇಳಿದಾಗ ಫಸ್ಟ್ ಕೇಳೋದೇ ಅದರದ್ದು ಪ್ರೆಷರ್ ಎಷ್ಟಿದೆ ಅಂತ. ಅರ್ಥ ಆಯ್ತಾ? ಸೊ ಇಫ್ ಐ ಸೇ ಅ ಬಾಯ್ಲರ್ ಇನ್ ಥರ್ಮಲ್ ಪವರ್ ಪ್ಲಾಂಟ್, ದೆನ್ ಇಂಜಿನಿಯರ್ಸ್ ಏನ್ ಕೇಳ್ತಾರೆ ಫಸ್ಟ್, ಎಷ್ಟು ಪ್ರೆಷರ್ದು ಬಾಯ್ಲರು. ಅರ್ಥ ಆಯ್ತಾ? ಈಗ ಸಿಮಿಲರ್ಲಿ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಮೋಟರ್ ಇದೆ. ಮೋಟರ್ ಬಂದ ತಕ್ಷಣ ಎಷ್ಟು HP ಮೋಟರ್ ಅಂತ ಕೇಳ್ತೇವೆ. ಕರೆಕ್ಟಾ? ಎಷ್ಟು ಜನ ಗೊತ್ತಿದ್ದಾನೆಲ್ಲ ಗೊತ್ತಿಲ್ಲ ನನಗೆ. when you speak about motors, we'll talk in HPs. How many HP motor? Yes or no? When I talk about AC, air conditioning systems, what is the unit that I refer to? ಯಾವ ಬೇಸಿಸ್ ಟನ್ಸ್ ಆಫ್ ರೆಫ್ರಿಜರೇಷನ್. ಎಷ್ಟು ಟನ್ AC ಇದೆ ಅಂತ. ಸಿಮಿಲರ್ಲಿ ನಾನು ಬಾಯ್ಲರ್ ಬಗ್ಗೆ ಮಾತಾಡಬೇಕಾದ್ರೆ I will immediately refer its pressure. So that is how the boiler pressure is so important for us. So if he says a Rankine cycle operating on a Rankine cycle at 10 bar anta helidre, it might not be clear for a normal student, but it has to be perfectly clear for an engineering student what he is talking about. Is that clear? So if he says operating on a Rankine cycle at 10 bar anta helidre, you have to be in a position to detect that is boiler pressure. Is that clear?
Yes, sir.
Good. So we will end the class here. We'll continue this problem. I have a small hint here. I think some data is being missing or some 2 lines are being missing. I'll just check on this because QS supporting data is being not given. I am not finding such data on this particular problem. So anyhow, if that particular data is available, we'll solve this, or else we'll go for another problem in the next class. Okay? Have a nice time ahead. Have a great day. Attendance refresh agila, I know that. If it is marked P, you just leave it there itself. Okay? Don't worry about that.